Hello, everyone, and welcome to today's live online Lunch and Learn, Effortlessly Immunize software, rapidly inoculate compiled code against software memory vulnerabilities, sponsored by RunSafe. My name is Jessica Gallos of SANS. To help make most of this presentation, I invite you to join our SANSFire Lunch Presentation Slack workspace. You can find a link to join in the chat box within Zoom. Today's featured speaker is Kenton Brazil. If during the webcast you have any questions for our presenter, please enter them into the Q&A window located on the control panel or in the Slack channel at any time. Please note that a copy of the slides and recording of this webcast will be made available for viewing and can be found within the SANS webcast archive. And with that, I'd like to turn the webcast over to Shane.
Thank you, Jessica. This is Shane Fry. I'm our VP of Security Engineering at RunSafe Security. I'll be handling the Q&A and questions, so please feel free to ask questions at any time. We will do our best to either answer those live or via chat. And I'll also be keeping an eye on the Slack channel as well. So if you have questions, you may ask them there as well. And now I'd like to hand it over to Kenton Brazil, who will be running the webinar for us.
All right. Thanks, Shane, for that introduction. And thanks to everyone on the call for tuning in during your break. I'll do my best to handle the learn portion of this event and hopefully teach you something new. Please feel free to relax and pick out whatever lunch you want. I promise no one here will judge you. As Shane said, my name is Kenton Brazil, and I'm the lead field/sales engineer for RunSafe Security. Normally, I spend my time on the road in both pre and post-sales support, technical efforts, basically. And luckily, with SANS events and tools like Zoom, we've been able to continue our outreach and interaction with customers and the cyber community. I know we don't have a ton of options for live entertainment right now, so at the very least, the fact that you're not watching a rerun or something else pre-recorded is unique. And as you will see, RunSafe Security is all about being unique. Speaking of reruns, my wife and I were actually watching The Office again, and it's certainly different in 2020. I find it interesting that despite all the seasons and all the episodes of the show tackling different aspects of how business is run, they never thought to introduce a plot such as a pandemic. It just goes to show you that even when you have smart people trying to think of every way to address something, you could be missing something significant. The same can be said for vulnerabilities in software. RunSafe knows this and approaches cybersecurity differently by tackling 0 days head on and baking in binary hardening into every line of code. As we all know, all software is vulnerable, and thus all software should be protected. Before moving forward, I want to hit on a few agenda-related items. The goal is not only to keep you from falling asleep, but also to teach you everything about the technology behind our product called Alkemist. We'll start with a few slides on what it is, how it works, and what problem it's solving, or said another way, why do I care? Most of my talk will actually be focused on guiding you through our online demos to both explain the technology in a hands-on way, as well as providing you with an introduction on how to use it on your own. To that end, and you will hear me say this a few times, your participation in this demo is highly encouraged, and you can access it easily through your web browser. The web address is alkemist.runsafesecurity.com, and you can see that link here, as well as in chat or in the Q&A. I'll remind everyone again once we start the demo portion. Explaining who RunSafe Security is better served by first addressing the RunSafe mission. The mission is to provide tooling to our customers to achieve one very specific and very important goal: to immunize software from cyber attacks. RunSafe was founded by practitioners of the cyber attack world who determined that the best way to provide defense for modern systems is to disrupt hacker economics by depriving attackers of the information and structure they need to build a reliable exploit. When I say hacker economics, we are talking about how defenders have to be perfect, while attackers only need to find one hole to get into a system or network. With our product Alkemist, defenders are able to transform that narrative and automatically disrupt any and all memory corruption exploit capabilities attackers once had. We integrate across build and deploy tool chains without adding developer friction, protecting open source, proprietary, and third-party binaries. We have customers and integration efforts across both the commercial and DoD markets. Our hope today is that you folks at SANS will see the value of this technology and the power it can bring to the defense of systems you care about. Let's look at how Alkemist directly addresses issues discussed in many of the SANS courses. This is just a small list of some of the courses you may be in and a few notes on how our technology is applicable. As we go through the tech explanation and the demo, more of this will become clear, but we wanted to set the stage in a SANS light to get you thinking about some of the concepts and methodologies you've heard in these classes. You will learn how we relate to classes in digital forensics by how we contain the attack. You'll learn how we aid in securing software development processes by shifting security left and reducing risk. Keep these highlights in mind, and I encourage you to ask questions related to these concepts. So we immunize against memory corruption attacks, but before moving forward, let's first define what that threat really is. Memory corruption attacks are using legitimate code to achieve unintended attacker-derived outcomes. Examples of these attacks are buffer overflow, stack overflow, heap overflow, use after free. In the analogy seen here, memory corruption exploits can be looked at as taking various letters out of a book and putting them together in an arbitrary order to create whatever evil outcome is desired. The crucial part of this attack is that the attacker needs to know exactly what the source code is. And I'm not talking about just knowing what the title of the book or the, you got to know the exact version, the language that it's written in, the year it was published, all of the finer details. In short, that's the key to the secret behind our technology. Taking those details and dynamically changing them on the attacker, making it impossible to find their targets. Vulnerabilities do exist in all code, and MITRE is a top source for tracking these. Seen here is the MITRE 2019 CWE Top 10 Weaknesses, which was also backed up and adopted by the DHS. 4 of the top 10 directly relate to memory corruption, including the #1 weakness by a significant margin, buffer overflow. These weaknesses are ranked out of a score of 100 based on frequency and severity. Buffer overflow is the attack we will demo today, and we will show how Alkemist defeats its attempted exploitation. These weaknesses are a measure of what types of vulnerabilities, including 0 days, are most lethal. These vulnerabilities are on the rise, up 325% since 2009. 70% of Windows patches are related to fixing these types of vulnerabilities. How do you protect your systems today from weaknesses such as these? What is the solution to this massive problem? Before looking at how Alkemist is evolving the practice of cybersecurity, let's look at what is available today. When you think of common current protections and cyber tools, something like this list probably comes to mind. Firewalls, VPNs, intrusion detection systems, identity management, static and dynamic testing, encryption, all of these are good and serve a valid purpose. However, what happens when these fail? What is the last line of defense before losing control of your system? What does it mean to incorporate defense in-depth strategies to provide true native cyber resiliency? These protections work around the underlying weakness, but don't neutralize the risk and solve the problem at the point of attack, which is in the software itself. Luckily, there is a solution. If you change the memory layout, you can cripple the attack. Address space layout randomization, or ASLR, is the first attempt at actually solving this problem. However, it didn't actually succeed, as it was merely a speed bump in the attack and not a complete roadblock. ASLR shifts the entire program as one unit around a memory, meaning that any information leak can give an attacker enough capability to find the targets. Alkemist is complementary to ASLR, but also necessary to provide complete code-level protection. While ASLR shuffles the program itself, we shuffle the internals of the program, giving that finer-grained randomization that prevents an attacker from being able to utilize that research base address and target offset. In doing so, transform binaries become logically unique, maintaining original program performance and functionality. The image on the right depicts this at a high level, showing the function layout in memory being modified via hardening. However, the control flow is maintained. As this is a pretty technical audience, I wanted to dive one layer deeper into how Alkemist actually works. In column 1 of this Hello World example, we see the original layout of the binary. It contains the header and the text sections containing the functions and basic blocks within those functions. Our source code transformation technique, which is inserted during compilation and is the focus of our demos today, is called load time function randomization, or LFR for short. In column 2A, you can see a depiction of the LFR randomization. If you look closely, you can see that while the program remains in the same place, the functions themselves within the program have been shuffled. Our binary-based transform technique is usable on any compiled binaries that we currently support. So ELF and PE files on x86, PowerPC, ARM, for example. This randomization is performed after compilation, requires no insight into source, and is focused on shuffling the program. It's not focused on shuffling the program or the functions within the program, but the basic blocks within those functions. In column 2B, you can see a depiction of this BBR randomization. Likewise, to prevent stack-based buffer overflows, we have a binary technique focused on adding an offset to the stack frame for every function. An attacker has to know exactly how many bytes to write to carry out a buffer overflow attack, and with the introduction of the random padding on the stack, that moving target causes the attack to fail. I'll pause here as we've gone through our first deeper cut into the technology and see if there is any questions.
Thanks, Kitten. Don't see any questions so far, but one question that we get asked often is, how do we get Alkemist? And so we got a couple different things. One thing Kenton's going to show you a little later is our self-service portal. One of the things that we kind of pride ourselves on is our ability to have our customers sign up and use the tool directly. And for those of you that are attending this presentation, we want to remind you that you can have a free 30-day trial of that. There's no credit card information required. You can go ahead and sign up and start using our Alkemist source capability today without any salesperson being in touch or any additional constraints there. We do support Intel, ARM, and PowerPC across our 3 different transform techniques, and you can get started with our source-based stuff today. So go to the website. We'll drop a link to that in chat, and you'll also be able to use that link later in the presentation if you want to follow along to demos in your browser. Back to you.
Awesome. Yeah, no, that's definitely good input. Definitely want to encourage you guys to participate. So for tool integration information, which is kind of similar to what Shane was just talking about, let's have a quick look at where the tool fits in software deployment lifecycles. This image shows an example CI/CD or DevSecOps tool chain. Alkemist source contains the LFR technology and is inserted at compilation and needs access to source code. LFR is capable of transforming proprietary code and open source. Alkemist binary, containing the BBR and SFR technology, is integrated with any compiled binaries, including third-party, and usually integrated during the deployment steps. As Alkemist source is the technology we will be demonstrating today, let's investigate it a little further. Let's look at the steps on how this technology is added to a program during build time. An example of a generic program's normal build process is listed at the top. LFR is inserted with a wrapper on the linker, which is important because we do not require our customers to modify their build process to use different linkers or compilers. The linker wrapper then creates a copy of the object files that contain the metadata. The original system linker is invoked, including the TextRP section, which contains the exact in-memory location of functions and bytes. Finally, the protected binary is created with the liblfr dependency, which is used to shuffle the functions after being loaded, and the entry point on the binary is modified. Let's see how the LFR protections actually operate when the program is running. For starters, it's probably worth pointing out that LFR is a dynamic-based randomization that actually happens every time the binary is loaded. That means that while all binaries are the same on disk, once they're running, they are all unique. Even on the same system, they are randomized upon each load. The way this happens is by inserting a shared library, liblfr, that is called and performs the randomization during the initial binary loading process. The entry point to the binary is changed, and you can see in column 2A, and using the function metadata fed to the library, the shuffle is performed as shown in column 2B. Then the program executes normally, starting with the original entry point as shown in column 2C. This process adds typically 1 to 3% of setup time, but has no performance change in the actual runtime process. Now that we have unique memory layouts at will, what does that actually mean in practice? If you think on the configuration management side of software and think about the one version running on systems that could be hundreds or thousands, or in the case of IoT, hundreds of thousands, those binaries being identical means that one exploit can propagate across all devices. Alkemist makes every binary unique in-memory layout, helping stop malware proliferation, reduce risk and attack surfaces of systems, increase cyber resiliency, reduce the need for urgent patching, secures the software supply chain, and provides an automatically applied passive last line of defense that is truly based off defense in-depth concepts. I know that was a lot of words, but seriously, this tool is really, really powerful. Now that I've got you totally convinced that you're missing out, how can you get Alkemist so you can effortlessly immunize software? And Shane touched on this, but we'll go into a little more here. Luckily for you guys, as he mentioned, we've just rolled out an exciting new feature on our Alkemist portal that allows users to get Alkemist in a variety of different ways. For each offering, there is an integrated step-by-step guide that will help you regardless of the platform or version that you need to support. I'll review this a little more in depth once we fully jump over to the portal for the demos, but it's worth mentioning here. Binary tools are delivered via VM or Docker and transformed as access through the REST API. I would be remiss if I didn't call out a significant clarification that this tool was designed and works efficiently in air-gapped environments. Obviously, for our standard free trial offering, you have to test in a dev environment in connected mode due to license checking. But for the DoD community, we support and have had success in delivering our tool and systems on closed networks. Last but not least, I want to quickly touch on some of our use cases. Let's start by looking at our government efforts. Just a few highlights. We're currently an approved tool in the USAF Iron Bank that is a cleared repository of tools for use in DoD software factories. We just recently won a SIGR Phase 2 to expand our technology capabilities in this container and DevSecOps space as well. And we have ongoing efforts in multiple projects within Lockheed Martin. They actually believed in the technology so much that earlier this year, LM Ventures actually invested as a Series A partner in RunSafe security. We also have a very successful ongoing effort with NavAir and GE, where we have hardened and validated the tool on a full authority digital engine controller on jet engines, and we are working on the next steps to get flight certified. Within the open source community, we also have partners in trial efforts. Open source software is a key use case for our LFR technology, as it is used heavily in IT infrastructure and due to the open nature has increased risk of attack. As we'll show in the demo, we've integrated LFR technology into many variations of compiled versions of servers, scripting languages, databases, and key libraries and dependencies. In addition, we are partnered with CloudBeast, JFrog, and Oracle, to name a few, to bring our technology as a joint offering through things such as plugins and instances readily available to be deployed on cloud infrastructure. Lastly, let's look at a few of our other commercial customers. Again, just a few examples here, mostly focused on the unique integration into the IoT and embedded space. Vertiv is one of our first clients and has been working with us for a while, automatically protecting their whole stack of software that is in their Yocto embedded environment. Bosch is also an early adopter and a key partner for us in getting into the automotive space. As you've seen, basically every market has a fit for this technology. Any software or infrastructure with vulnerabilities, which is, again, basically all, software that has a difficult or timely patch process, or if there are no patches available and that software is actually legacy code. Dual use systems are also key because adding a variation between a public and private version of the same software is extremely useful. This is a focus for the DoD as is the ability to help accelerate ATO. Even in commercial where ATO is not a consideration, it can help achieve systems certification and accreditation. With this last slide before the demos, I want to take a quick second to tell you exactly what we will be doing. This is the part where I encourage group participation and hope you will follow along. The first step will be a quick site review and registration for those of you that haven't done it yet. You'll want to do that to unlock the demos as well as your 30-day free trial offering. And again, the link is listed and highlighted here. Then we'll walk through 2 of the online demos on LFR, building software using LFR and exploiting a program and mitigating that exploit with LFR. Before we swap over, I'll take another short pause for questions.
Thanks, Kenton. No additional questions have shown up yet.
Okay. So at this point, we'll shift over to the RunSafe Security self-service portal hosted online. As our demos are live and interactive for all registered users, again, please feel free to follow along as I walk through the screen share. Now that we're looking at the home page, let me explain a few features of the site. In addition to hosting a few of our product demos, you can access the multitude of deployment options for Alkemist Source. I'll click on Deploy just to show you what I'm talking about. Here you can see all of the various platforms LFR can be installed on. I'll just pick one here, Debian for example, to show you what happens. Now we have a simple 4-step guided process, including commands that you can copy directly into your environment. While the technicality of these steps might change, the general procedure of installing LFR, building with LFR, and verifying the transformation of the binary is standard across the board. We encourage you to visit on your own and utilize the site further than what we will do today. Going back to the homepage one more time, I want to point out our Alkemist pre-hardened open source offerings. Clicking on one of these applications will take you to our guide and the beta tool for an installation of these enterprise software protection images. If you utilize common open source tools in your product environment and want them immunized out of the box, you can just point to our Docker repositories and get the latest version of the software you're using today. Finally, before moving on to the first demo, I want to show you where your license key can be found. Clicking on Account and then the license key will give you the option to copy it into your environment. This is what you'll need to do to perform any builds with Alkemist LFR. All right, that's enough time wasted. Let's actually get to the cool stuff. On the screen, you can see the demo tab with some notes at the top on the environment and the list of the 3 currently available demos that we have today. The online LFR demos are focused on showing the full story of building with LFR, protecting, and integrating this technology. Building with LFR shows the process of incorporating LFR on your own and in your own environment. Exploit mitigation focuses on providing the Alkemist hardening technology against a live exploit, specifically a buffer overflow vulnerability with a ROP attack. These are the 2 demos that we will be going through today. Let's click on Go to Demo under Building with LFR to get started. So to explain a bit of what you're seeing now, the left side of the screen shows the steps and instructions. The upper right shows a live text editor to actually change the code, and the lower right shows the terminal to run commands. For this demo, we will be building the official Redis 5.0.7 Docker file with LFR enabled. For reference, Redis is an open source database. We chose it for this demo because it is a commonly used open source tool and because it builds fairly quickly. This technology is also very capable and has been tested and validated against a wide variety of other open source products, as you saw elsewhere on the deployment page. We can click Continue to move to step 2. The first change to the Docker file will be to add a new stage. We need to add the RunSafe Security Alkemist LFR Alpine image that contains the LFR code and executes the license verification. While this demo is using Alpine, there are many flavors of Linux that LFR can work for, with the deployment page explaining the other options. You can see in the box the difference in files and the code input needed. I could go to the editor and add the from line manually, but to save time and avoid fat fingering, I'm just going to click the copy to editor shortcut. Once it shows up and we know it's there, we can click continue to perform a check and proceed to step 3. The next step focuses on copying files from the added LFR stage. We need to enable the LFR root path environment variable and use the copy command to add the LFR files we need to the proper directory. In our example, we want to place these commands as close to the build steps as possible to improve caching. Clicking the shortcut shows the highlighted text has been added to the Docker file. Click on continue to move on to the next step. For the third step of editing the Docker file, we need to insert the LFR helper script. The script does the heavy lifting of actually integrating LFR with software during compile time. More technically, the script adds arguments to the compiler and linker to enable LFR functionality, as well as making sure the compiler calls the linker wrapper. We do this so customers can use their own linkers and aren't forced into an additional change to their build process. Let's now click both copy buttons to prepend the LFR helper script to the original Dockerfile make commands. Once you see those highlighted and added, let's continue to the final step. In this step, we will add the LFR cleanup script to remove any excessive files that won't be needed during the hardened binaries runtime. Some of these examples are your license key and additional binaries. We'll place this call after the final build cleanup in the existing image. Again, we copy to editor and verify that it's there. And now let's actually continue to building the image. At this point, we are finished with modifications to the Redis Docker file and are ready to build. We can perform a Docker build command as normal, with the only change being the addition of the Alkemist license key argument. If you'll notice in the terminal, it should say that your license key has automatically been added as an environment variable, as it does on the screen here. We automated this input for you as part of the registration process. We can type in the build command into the terminal window, but considering it takes close to a minute to build, let's go ahead and use the shortcut. And now you can see the build actually kicking off in the terminal window. You'll see the various steps happen that would normally happen in a regular Redis build, such as copying files and installing various libraries. While this finishes, let's go ahead and click continue to move to the next step. In this step, we want to verify that the built Redis binary is protected with Alkemist. To do this, we need to check to see if the LFR protections are enabled. The guide provides a handful of options for testing this. We can verify that the Alkemist shared library is present and co-located with the file, or we can actually spin up a container and check to see if the shared library is being used, or look for changes within the binary itself, such as additions to the TextRP section. The shared library liblfr is a proprietary key component to the dynamic randomization process that happens every time the binary is loaded. Now that we see the binary has successfully built, let's check to see if the library has been added using method 1. By clicking on the terminal shortcut, we should see liblfr as output. As we do see it and we can verify that the transform was successful, let's continue to the final step. The last step for this demo is to verify that our hardened LFR enabled version of Redis indeed works functionally the same as the normal version built off the original Docker file. To do this, we will take the steps listed here and create a Docker network, use our hardened Redis server that we just created, add data to it using a third-party GUI called Redis Commander, and verify the added information. Using the Docker network command listed here, we will stand up the network via terminal. And now let's start a container on the new network and call it Redis LFR. And then we want to start the Redis Commander container on the same network and connect it to the previous container by clicking this shortcut. And as you can see, now there is an additional terminal and both containers are networked and running. Now we want to test adding data to the server. Clicking the link listed here will open the Redis Commander GUI in a new tab on your browser that is actually linked to the container started in the previous command. The next few steps will happen in the GUI, and then we will return to the demo portal. So first click on the hardened server from the list, and now click Add New Key to pop up the Add Key entry fields. This will allow us to add data to our database. So let's go ahead and add key foo with value bar and leave the type as string. And then we can save this and then swap back to our demo portal. Now we can retrieve that data using the Redis CLI. Clicking the next terminal command will open yet another terminal and connection to the hardened Redis container. Now that we're connected, let's get a list of keys to see if the one we added is here. As you can see, it is there, and let's finish by pulling a git command on that particular key. The database is operating as normal while being protected from exploitation against an entire class of attack. Clicking continue will bring up the survey and a link to the next scenario, which is focused on using these protections in a Hello World program to stop a ROP attack. Before we continue, I'll take one more pause for questions.
Thanks, Kenton. So we get a question from the audience on what packaging mechanisms do you support? So the demo that we're walking through today is with Docker, but if you go to our deployment page, you'll see that we support deploying Alkemist LFR in Debian packages, so Debian Ubuntu, RPMs for CentOS and RHEL systems. We also have support for Alpine if you're doing Docker, and we also have an integration with Yocto as well.
Awesome, great question. All right, so as we start the next demo, the first thing you'll notice is that a Docker image has begun building automatically in the terminal window. This is actually building the unprotected Hello World binary that we will then modify by adding Alkemist protections to it in the same way as the previous demo, and then comparing the outcomes of a ROP attack against both images. Let's look at a quick summary of all the components needed to make this demo work. Verify password is a simple program written in C that is performing a typical password authentication check. If the password is correct, it returns a secret phrase. One of these additional files is an external library that is used in this program called demo lib check input. In our demo example, verify password has been released as ready for operation, but was released with a 0-day vulnerability relating to the buffer on the password input function. Even worse, the library contains an executable payload, specifically a system called a bash, that was intended for debug purposes only, but accidentally left in the final release. These two pieces make up key components of an attacker's kill chain, and as you will see when we go through the demo, minor mistakes that weren't caught lead to the unintended consequence of losing control of the system. The last piece of the kill chain necessary is the exploit verify password Python script. After an attacker researches the binary, finds a vulnerability, and develops a repeatable exploit, this script is an example of what the attacker would use to actually carry out the attack. Let's look a little deeper at this exploit file. First, we need to find the base address of the library in memory and the address of the ROP gadget. Next, we need to fill up and overflow the unchecked buffer to redirect the return address to the call bash helper function in the library, which contains the payload, in this case, root access. This is done instead of the original functionality of the program, which was returning the main. Finally, this input into the verify password function with the ROP exploit as its argument is the last piece of the puzzle we need to achieve a successful attack. As you can see, a known stationary recurring memory address is critical to taking this devastating attack out of an attacker's lab and into the field on enterprise systems. It is with insight like this that RunSafe focused on and leveraged to flip the tables on bad actors by changing hacker economics and forcing attackers' targets to go mobile, and thus eliminating the repeatability of attacks like these. Now that we've gone over all the demo components, let's continue to the next step. This step is just verifying that the original version of the Docker image was built properly. To do this, click on the terminal command looking for images. And as you can see, that it was indeed just created a short time ago. So let's now continue to actually executing the exploit against this image. In this step, we will use our established kill chain to take control of the unprotected image we just built. The first terminal command is proving the original functionality as stated before, entering a password to receive a secret phrase. In this case, our password is super secure and the output phrase is the RunSafe slogan, 0 days or numbered. The additional text sort of listed here on the side is just to recap the steps happening behind the scenes to make the attack successful. Now we will run our Python attack script in the same environment by clicking the terminal shortcut. As you can see, the script correctly found and logged the base address and the ROP gadget offset to that address and used that information in the string which overflowed the buffer. At first glance, you might think the program worked as intended because of the notice of incorrect password being displayed. However, due to the buffer overflow that redirected the return of the function to the payload in the library, a shell prompt is now running within the container. By typing in typical commands such as ls or who am I, you can see that an attacker now has complete control. Let's exit this state and see what this lethal attack does against a program protected with Alkemist. Before attempting the attack, we have to modify the original Docker file and rebuild with LFR protections integrated into the vulnerable program. As you can see below, the steps are basically repeats of the steps from the previous demo where we built a third-party open source database with LFR. Let's repeat these steps now on the Hello World Docker file. You got to make sure it's open first. So now let's add the image as a stage via the new from line, and then let's copy those files into the original build stage. Then finally, let's prepend the LFR helper script to make the make command and add the cleanup script to remove any unnecessary files. Now that we see all changes to code have been made, we can perform the Docker build command again with the license key build argument. If you are following along, registered for an account, and are still signed in, the license key should be set in your environment automatically. While this finishes, we can go ahead and continue to the final step. This last step focuses on two things: proving identical functionality and proving Alkemist protections work against the exploit. Just to refresh, let's rerun the first two commands on the original binary to show the original program functionality and the effect of the ROP attack. So again, showing the password input super secure and the output 0 days or numbered. Then the exploit, which opens up root control in the container. The next two commands are the exact same, just executed against our Alkemist protected image. First, we verify that the functionality is the same. As you can see, the password authentication program still operates as normal. Running the second command and attempting the Python exploit, you can see that LFR has successfully randomized memory layout, immunizing the software and preventing the attack. Due to the attack failing to hit its target, a shell is not open, root access is not attained, and the container stays secure. In looking at this side-by-side view, it's easy to see how a simple solution such as adding in randomization is crippling to the biggest threats to cybersecurity today. Finally, clicking continue takes us to another demo review page and concludes our second demo. With that, we have a few more minutes and we'd be glad to answer any final questions.
Thanks, Kitten. I'll give people a minute or two to ask any additional questions, but at the moment, I think we've answered all the questions.
Okay, as we await for additional questions, Kenton, did you have any closing thoughts on anything?
No, I hope everybody learned something today and enjoyed themselves and definitely just again, I feel like I keep saying this, but definitely encourage you guys to kind of get out there and play with this a little bit because it's very unique and very interesting and very powerful. You know, the wide variety of environments.
Okay, great. Thank you.
Also, thank
Shane?
you to SANS as well for hosting this, of course.
Thank you. Shane, do you have any other questions or closing statements?
I think we're good.
All right, thank you. Well, that's all the time that we do have for today. Thank you so much to Kenton and Shane for hosting the Q&A, and Kenton for that great presentation, and also to RunSafe for sponsoring this webcast, which helps brings this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcast. Until next time, take care, and we hope to have you back again real soon.